Hello, my name is John Schroeder. I reside in Mid-Pines, which is a community in Mariposa County, California, and I work for the Mariposa County Resource Conservation District. This presentation is part of a series of 4 which deals with dead trees caused by bark beetle infestations, specifically that of native bark beetles in the Sierra Nevada. The first presentation, this one, is a brief introduction to our beetle problem. We call it the beetle complex. The second presentation in the series is residential hazard tree removal. The third deals with logging operations in the landscape with log removal. And the fourth is logging operations in the landscape but without log removal. I wish to thank Beverly Bouillon, forest entomologist with the U.S. Forest Service, Region 5, for her assistance in reviewing this presentation. So let's continue by discussing the beetle complex.
There are 3 different species of pine beetles that are primary with respect to ponderosa pines, and there are many other bark beetle species that attack other tree species. The most common beetle species, and the most threatening to ponderosa pine trees in our region, is the Western pine beetle. Different species of beetle have different tree diameter preferences, and the Western pine beetle typically prefers the center segment of the tree, as shown in the diagram. Also seen in our forests are pine trees that are only having the top dying back, typically down to a diameter of approximately 6 inches. The culprit here is the engraver beetle, or IPS species. This kind of infestation may or may not be fatal to the tree, but does weaken the tree, making it susceptible to other damaging agents. Finally, there is the red turpentine beetle, which usually attacks the bottom 10 feet of the tree. How do the beetles operate? The beetles eat a hole in the bark of a living tree. Once inside, they mate and lay eggs in the nutrient transport layer of the tree. Their larvae feed on the transport layer, which carries nutrients up from the ground, and eventually girdle the transport layer, killing the tree. The beetles also introduce a fungus, which produces a blue stain in the wood. This fungus possibly helps overcome trees' defenses. They are able to kill trees over a wide area, particularly if the trees are stressed by drought. The combination of hot weather and drought weakens the tree's natural defenses. The Western pine beetle is not an alien. It's a native inhabitant of our forests. It is the combination of climate change, current forest conditions, and stressed trees that have caused the loss of over 100 million trees in California. When the beetle bores into the bark, the tree tries to push the beetle out with pitch, or resin. This produces visible pitch on the outside bark, called a pitch tube. But some trees can be so weakened by water stress that there may not be visible pitch tubes. As such, it is important to look closely for signs of boring dust in bark crevices, especially if you notice the crown is changing color. Pitch tube colors can indicate successful or unsuccessful attacks, but it's still recommended to make a complete assessment of the condition of the tree. It is easy to detect beetle presence in the landscape. Looking at a tree that has been infested and dead for a time, you will see patches of bark missing. You will also see holes in the bark where woodpeckers have gone mining for beetle snacks. You may even see the birds themselves pecking away. And take a long-range look at a stand of pines on a hillside. Beetle infestations travel from tree to adjacent tree. The beetles leave a dying tree and move to a live one nearby. If you see what looks like little white golf balls on the side of a dead tree, the tree has been infected with pouch fungus. This means that the tree has lost its internal structural strength and is unsafe to climb. This will cause problems if the tree is near a house and if your contractor needs to climb it to attach lines, or the tree needs to be sectioned down by the climber. Unsafe to climb can be caused by other factors, and the climber must decide on whether to climb or not. So this concludes part 1 of the Tree Mortality series. We hope you will continue on to view the other presentations in the series.